So, hi, hello everyone. So, we'll start our session. We'll just wait for 1 or 2 minutes and then we will start. So, what we are going to do today is we will discuss previous year's questions on digital image processing, and then after we will start resuming our sessions on QGIS. So, hello. So, as I discussed, today we are going to solve some previous year's questions on digital image processing, and then after we will try to finish our portion on QGIS, which is like related to the vector analysis, and we will also try to finish a bit of stuff on raster analysis as well. So once we are complete with the analysis related to vector and raster, in the next lab, so next tutorial session, entirely we will focus on gate second part, which is on like digital image processing only on electronics part. So that portion is a bit big portion, so we cannot cover along with the QGIS session. So today we will try to finish our QGIS portion a bit, basically vector and raster data. And then in the next lab, we will finish, like we'll try to solve all the MCQs from uh, last 3 years of the paper from GATE. And then in the upcoming next to next lab, we will try to see some of the applications related to image classifications as well. So, and the other one more thing is like why we are not covering some gate papers today is because some few topics are still there to cover in digital image processing, such as image classifications and all. So because like most of the questions will come from that only. So once that part is like completed, we will try to do that thing. So with that, let's start today's session. So hello everyone, my name is Hireen and I am a PhD scholar at IIT Gandhinagar in the discipline of Earth Sciences, and I am taking this doubt session or problem solving sessions of Advanced Geomatics Engineering, and we are in the week 9 and we are having this doubt session every Monday 7 to 9 p.m. And in between, if you lost the meeting or lost the connection, join the same meet using the same link which we have provided to you. With this, let's start our today's session. So here, there are some cases where in satellite images you will be having some this kind of lines. So which is because of the there is some systematic errors are there in the sensors. Because of that, you can see this kind of lines are visible. So this kind of lines which you can see here. So these are known as a drop lines in satellite image are normally corrected. So if you want to correct this
Hello?
particular, yeah. Oh,
Excuse me, I'm so sorry. I think your screen is not shared.
just sorry about that. Is it visible now?
Yes, visible.
Okay. So this is one of the satellite image, and in satellite images sometimes you will see this kind of lines. So this black color lines you will see that is because of some kind of systematic error in collecting the data sets. So if you want to correct this particular lines or this particular image, so that is the first of all that line is known as a drop lines, which is coming because of the systematic error. And if you want to correct this line, what you can do is you can take just a pixel on the above of this line and the below of this line, and you can take an average of those two pixels and put that value as a this line. So that is one way. So like if you have this kind of line, how to correct that? So using this kind of averaging, or you can say mean, if they ask you in terms of writing that write down what kind of operation you will perform. So either if the answer is average or mean. So drop lines are normally corrected by replacing the line with the mean or average of pixel values in the line above or below. Then we have the another question, which is like radiometric distortions are caused due to. So first of all, in the starting of the week, we learned that radiometric resolution is like how much sensitivity we have. So it will be defined by the number of bits that that image can have. So like if 8-bit image is there, then it can store the value till 2 to the power 8. So if that kind of distortions are there, so that is caused because of which issue. So like in PPT, you will see this radiance measurement by any sensors over object is influenced by the change in scene illumination. So scene illumination means that if you are collecting data at 10 a.m. or if you are collecting data at 4 p.m., sunlight condition will be different. If some clouds are there, sunlight condition will be different. So light which is going back will be different according to the illumination conditions. And what we are getting as a radiometric resolution is how much sensitivity that pixel has. So if clouds are there, we will not have that much sensitivity because all the pixels will look similar, kind of haze or white color of kind of pixels. Similarly, if darkness is there, so we'll not get the proper pixel value or the intensity which we should get. So the scene condition will affect. Apart from that, second thing is viewing geometry. So how viewing geometry will affect this? Let's say the satellite is on top of us. So the like light will directly come to the object, and in that case scattering and absorption, whatever the phenomena which are happening, because like it is at exactly at 90 degrees, so it will not it has to cover less distance compared to if it is there on horizon. So if it is in horizon, like sun angle is in horizon, so light will take time to reach to the point, and because of that scattering will happen a lot. So how you are viewing the object from the top or from the horizon, like some angle with the horizon. So that will also make significant like difference in the DN values. And then the sensors characteristics. So let's say if we have some sensors which is sensitive to record some variations up to 4 bit only, some sensors which can measure the sensitivity till 8 bit. So it is just like what kind of sensor is there and what is the technical specification of that particular sensor. And then we have atmospheric conditions. So atmospheric condition, it means the clouds cover is there, haze is there, or some water vapor is there. So it will also influence the DN value. So here, if we talk about the radiometric distortions are caused due to, so it is due to the atmospheric condition, change in scene illumination, and sensors characteristic. The first option is not right because relief displacement will cause the error in the geometric error, because of which like there is the issue in the geometry, not in the radiometric distortion. Then in the last lab, we learned about the georeferencing. So now, if we want to do georeferencing operation to correct our image for for the given geometric distortions, so how many GCPs are required? So let's say if we want to do linear kind of transformations, so in that case, as is given here, we just need 3 GCP points, which is useful when we have small area or flat areas. Then if we have some areas which has some kind of moderate terrain or some kind of ups and downs are there, then to do that kind of to process georeference thought particular areas, we have to do with second order georeferencing, which requires at least 6 point. And then third order georeferencing, if terrain is very rugged and too many ups and downs is there, or the elevation difference is too much, then we can have this third order georeferencing or transformation, which requires minimum of 10 number of GCP points. So here it's like given that this is the minimum requirement, but it is not like that. You can take more number of point also to get more accuracy. So here they are talking about first order polynomial transformation. So for first order, 3 number of GCPs are required. If they ask you second or third order, correspondingly 6 and 10 GCPs are required for that particular purpose. Now, when we talk about this geometric correction, so why do we need geometric correction? So that is like there is some like our image is distorted because of the change in elevation or some of the other thing. So this you can see whatever the parameters which can cause the geometric distortion. It's like panoramic distortion or because of the Earth's curvature or atmospheric refraction or the relief displacement. So I think most of the things you have learned in the previous classes because of which geometric distortions will occur. And then to remove those kind of correction distortions, we need this geometric correction. So once we apply this geometric correction, what we are doing is we are assigning the pixel coordinate as we did in our previous GIS hands-on, that we have one base map and then we assign the coordinates at every four corners, and then after we transform the data using the linear transformation. So we have given the four number of GCP, but minimum requirement was three, but we have given four, and then we geo-reference that given image in the last class. So once we define the coordinates, and then we can also define the size of pixels. In that case, we can change it also, and then how it is related to the other pixel. So in that particular window, we have also selected the resampling methods as well. So those things we will do, and then after we will do the geometric correction, which is required to first of all, like it is necessary to remove the geometric distortion. So that is a first use. Then second thing is if we want to change the coordinate system of the image, or if we want to change the pixel size. So all those things, like if we have different maps, topo sheets, so we can combine so many topo sheets and we can create a mosaic out of it for given district or given state. So those kind of things we can do if we geometrically correct the image. So basically here you can see the first thing, we can also change the projection system of our image. We can change the pixel size and we can eliminate the distortion. But topology error we cannot correct using it because it is something else which is not covered in the geometric distortion. So option A, C, and D is correct options over here. Then we have this cubic convolution resampling. So in GIS, if you have seen we have linear transformation, then nearest neighbor resampling method, then cubic convolution, then the second order was also there. So if we are having this cubic convolution method for resampling, so how many nearest points are necessary? So for that, 16 nearest cells are necessary to transform the data, like to get the value of nearest pixel. And it is like useful for continuous data where the topography is quite like hills and valleys kind of these things, then it will be helpful a lot. Then we have the next one is like image mosaicing. So mosaicing means stitching the different images together. So if we want to do this thing, then what we have to do is first of all we have to geo-reference the different images. And once we geo-reference the different images, then we will resample it together and make it com combined one. So here we do not have to do just georeferencing or just resampling. We will do both the operation. First, we'll do perform the georeferencing operation on all the images, and then we will resample them into one single image. So those two operations we will do during the image mosaicing. And then the blank is the image of graphical representation that provides the frequency of occurrence for each intensity level in the image. So if you have some image like this and we want to see that let's say red color is there, so how many times red color is occurring, how many times blue color is occurring, how many times yellow color is occurring. So this will give the is known as a histogram. So it will give the intensity of each and every color or each and every digital number. So like you know that image is made up of different pixel values. So how many times this pixel value of 50 is repeating. So if you just have idea that image can have the value from 0 to 255. So we can see over here that how many times 100 is repeating, how many times 50 is repeating. So on x-axis you will have the digital number, on the y-axis you will having frequency. So that graph which will give this kind of distribution, that is known as a histogram. So it provides the frequency of occurrence of each intensity level in the image as a graphical representation. In today's lecture, we will see some kind of histogram, how to plot histogram also in QGIS. Then we have this property of logarithmic enhancement. So in the slides, you have this particular enhancement methods uh, for image enhancement method. And then this log enhancement methods is having like lower amplitude of image input image, the range of gray level is expanded, and higher amplitude of input image, the range of gray level is compressed. So according to what kind of values we have in the digital number, either we will expand it or compress it. If like it is changing too much, we'll compress it. If it is too low, then we will expand it. So for lower amplitude, it is less, so we will expand, and for higher, it is high. That's why we'll compress it. So option B and C is correct over here. And then we have the different filters which were used in that class. So basically, we have the low pass filter and high pass filter, which is known as a smoothing. Low pass is known as a smoothing filter, and high pass is known as a sharpening filter. So you just have to match the followings. And then we have the last question on which one is not a correct statement for this Laplacian or transformation versus gradient transformation. So this Laplacian transformation is localized and it is good for detecting edges. As you can see in this particular image, it can easily detect the edges, but higher order or the more number of edges is not like it's not uh, able to capture because it is more sensitive to the noise compared to the objects or edges which are there in the image, and it is less computational expensive because it's just doing the edges, whereas this another one, the gradient one or the Sobel one, is like you can see it's giving more idea about the edges and the edges of the objects or these pieces also. So this Laplacian can provide the H directional information. That is true because you can see here. Then Laplacian localize the edges better. That is also true. And then higher like so you can see Laplacian localizes the edges better. And then higher order derivatives are typically more sensitive to noise. So you can see that thing also. So that is like questions. Now we will start with the QGIS. So if you have more questions on digital image processing or something related to that, please write us on the classroom. And the what we are like I'm planning is in the next lab, we will cover it entirely on digital image processing. So we will discuss in more detail with some practical insights if it is possible in QGIS in the next class. And meanwhile, we will try to do the vector and the raster data sets. So we'll see some of the applications of histogram, but like additionally, we will see in the next class. Any quick question or if any doubt is there or point if there is there, we will cover it in the next class, or you can just write it down or we can discuss afterward. Yeah, if it is not there, then we will start with the QGIS. So all of you can open the QGIS in your system. And today what we are going to do is we are going to start with the vector data sets. So I'll give you time to open your systems. So today we are going to deal with this data sets. I will just highlight the folder which we are going to use today. So today we are going to use this day 4 and day 5 folder. Day 4, day 5 and day 6 folder, vector selection, buffer analysis and overlay analysis. So I'll give you 1 or 2 minutes so that you can open your QGIS. If it is already open, just let me know, then we can start. Go ahead.
Yeah, it is open.
Yeah. So in that case, we'll just go ahead with the hands-on. So first of all, we'll start with the vector data sets. So here you can open the folder facilities underscore Gujarat, and there you have the file named as facilities.shp. So under facilities underscore Gujarat, you have one file facilities.shp. So you can open
Yeah,
it.
good.
So this data I have downloaded from that Pradhan Mantri Gram Sadak Yojana website, which I showed you in the last class. From that, I had downloaded this particular data sets, and you can also open the this particular shape file, Word Office, or sorry, this you can just click on this AMC facilities.kml file, drop down, and from there you can just open this 48 underscore new wards. So under this AMC facilities.kml, you can open this 48 underscore new wards file. So now, first of all, we will examine our data sets. So we have two particular layer. One layer is representing facilities and one layer is representing a Word file. So first of all, we'll go to the Word file. We'll just go to zoom to layer. We'll click on zoom to layer, and we will see that now this is Ahmedabad shape file. But if you don't know, then what we can do is we can add the base map every time when we don't know anything about the data. So I will add the base map. So I will add the Google Maps only. So we'll get the so this data is representing Ahmedabad. Okay. So now what we want to do is, let's say first of all, this facility data are given. So first of all, we will examine what kind of data it is and what kind of information is there in this particular data sets. So for that, first of all, we will right click on this facility layer and then we will go to the properties. Now in properties, we'll go to the information, and in information, we will see that this coordinate system of this data is WGS 84 and units of the data sets are in degree. So that thing is clear to us that coordinate system and units of this data is in degree. Now to see the other information, we will right click and open the attribute table. So when you open the attribute table, you can see there are different attributes are there in the given file, such as you have the first thing is state ID. So this is the data related to Gujarat only. So state ID will be same for every point. Then you have district ID. So depending on the different districts in Gujarat, it is having this district ID. Then you have inside the district, you are having block ID, habitation ID, then facility ID, then facility description and facility category. Now, if you see these two options, because others are like numbers, and we do not know that which particular number represents which district, or we do not have any metadata related to this. But we know something like in this two particular column that it is just giving the description of the given file, that it is a milk dairy or ITI or cold storage or shop. So something is given to us, whether it's a bus stand or something else. Similarly, over here, if you see in the facility category, so we have agriculture, means agro facilities, educational facility, then we have transport or admin facility. So three unique thing is there, but we will check that how many unique values are there. We also have medical facilities here. And if you want to just organize your data by ascending or descending order, you can just click on this particular attribute. So facility description, or you can just click on facility category. So it will organize your data in ascending or descending order. So we just analyzed our data. So this is having such kind of thing. Now we will close this table. Now let's say this data is related to the facilities. Okay. And let's say I want to see how many, let's say we have seen that in data, agro facilities were there. So we want to see how many agriculture related facilities are there in the entire Gujarat. So what we want to do is we have bunch of data sets. From that, we want to extract the specific data. Let's say data which represents agro only. So we want to extract that data set. So how to do that? So for that, if you want to analyze any vector data, there in the processing toolbox, you have one option known as a vector analysis. Or sorry, you have vector selection. Basically, you want to select some data from the given vector layer. So you have this option, vector selection. So here you see there are around 9 or 10 tools are there, which is starting by extract by attribute, extract by expression, extract by location, random extract within subset, random selection within submet, within subsets, or select by attribute, select by expression, or select by location. So if you see here, there are three important words are there. The first one is extract, then second one is a random, and the third one is a select. So here select it means that it will just select the facility which you will give. Let's say you ask a question that select the medical facility. Then it will just select the medical facility. When on the other hand, if when you do this extract tools, then what this extract tool will do, it will extract the medical data and create a new file which will have the medical facility. So wherever the word select is written, it will just highlight the data point which is medical sector. But if you use the extract button or extract tool, then it will create a new file for that particular expression. So we will learn this by doing this. So first of all, there are three in extract also. There are three different tools are there: extract by attribute, extract by expression, and extract by location. So if we go to the extract by attribute and then
Eden,
yes,
I have lost my processing toolbox. Where do I find it?
okay. So if you lost it, so you can go to view, you can go to panels, and there you can just click check box on processing toolbox. If it is it showing there?
Not there. It's not there. That's what I searched over there. I couldn't find it. That's
Okay. So
why I.
in that case, you go to plugin, manage and install plugin,
Mm,
and there you just write the processing toolbox.
mm, mm. No, it's not there. I think there is some problem with my QGIS. I'll just restart because it doesn't get lost usually like this. Just give me 2 minutes. I'll restart my
Okay,
QGIS.
okay, fine. So this tool is also present over here as well. You go to plugins and inside that installed, and you can find out the processing is also there as well.
Hire, I'm so sorry. I don't want to
Yeah,
disturb you. So you can continue. I will try side by side. I will
okay,
learn. Yeah,
okay,
yeah.
okay. So I will just give you a few more things that if it is not coming from view, you can use plugins. If it is not coming in plugins, you can just see here also processing menu is there on the menu bar. There also, if you click on toolbox, it will show. So if you just I just removed it, I just added it. So three ways are there by view, panels, and processing toolbox. If it is not from there, then from plugins, manage and install plugins, and then in that installed plugin, like if you just open it, or there you can just see the under this installed and just see under the processing. And if it is not there, also you can just this menu bar also, which is named with the processing. So you can just check these three things. If it is still not there, let me know. So here it is first tool is extract by attribute. So attribute means what? Here if in facilities file, we have seen the attribute table. So in that attribute table, you have the state ID, district ID, block ID. So what we want to do is that this attribute is there, such as facility category. So we will write that facility category should be agro. So we are giving one condition that facility category select the point for which facility category is agro. Okay, so extract by attribute. Now first we will select the layer from which we want to extract the data sets. Then after we will select the attribute which we want to use as a condition. So here you know that we want to use our last field or last attribute, which is facility category. And then we want to equal it. So it should be equal to agro. So I will write agro there. And then after I will save my file and just click on run button. So once I will do this, what it will give me, so you can see I will now remove my facility layers. So now I have end up with all the files or all the points which are related to the agro only. So now I am having only points of agriculture or the agro facilities, which might be a dairy or some kind of cold storage or something or else. So you can see we have all the points which is related to the facility categories agro. Now, the second thing is within this agro, uh, let's say we want to find how many of them are having something related to the milk. How many of it are related to the milk or milk production or milk dairy or milk storage or milk center or anything, but it should have word milk associated with that. So we want to do further extraction. So here what will happen that we have to use this facility description because there this milk is written. Here in this facility category only agro is written. So we have to use this particular attribute. But now when we will use this particular attribute, we also have some other words along with milk, such as milk space dairy or this Sudan milk space center. And you can see here the word milk also has different ways. Sometimes M is capital, sometimes M is small, sometimes milk is coming as initials, sometimes it is coming in between. So we are having this kind of disparity. So how to avoid those disparities and then how to select or extract the all the facilities which are related to the milk. So first of all, now I will use this extract by attribute tool. I cannot do it because if I select this facility description, then here the options are very less because see begins with so because it is not exactly milk, so we cannot use any of this operation. Now every time it is not beginning with the word milk, so we cannot use this also. We can use this word contains, so either it should contain word milk, but the thing is here M can be small also, M can be capital also, so we also don't know that, so this will also not work. So for this kind of extraction, this extract by attribute tool will not work. So for that we can use this extract by expression tool. Okay, so extract by attribute is useful when you just want to have just a single field and your field is having like very limited operations such as less than, greater than. So find out the library facilities which are having the annual fee of less than 2000 or the gym facilities which are having the fees of greater than 4000. So if you this kind of stuff are there, you can use this extract by attribute. But something related to names are there, then it's better to use this tool extract by expression rather than using extract by attribute. So here what is the extra thing which you will get is here you can frame your own expression. So I will select the now I will select using the extracted facility only. So now here you can click on this particular expression bar or this sigma button, epsilon button, and then you will have this, you can generate your expression in this particular dialog box. So first of all, we need to use the field facility description. So here you can use the fields and value tools is there. So it will show you all the fields or attributes which is present in your shapefile. So I will select this facility description layer because I want to use that. Now, if you click over here, all unique, it will show you all the unique facilities which are available under this particular shapefile. And now, if you want to find out something related to the milk, you can write word milk and it will show you the different things related to the milk here. So dairy milk, this particular district or state name or some of these collection centers are there, dairy centers are there, production centers are there. So you can see clearly that word milk is coming either in between, either in the initial, either M is capital, either M is small. So we have to consider all those things. Either all the four letters are capital. So first of all, think that if you want to contain word milk, then there is an operation named as I like. It means it should like milk. So I will just, you can just explore those things under the search bar also. So if you write here I like operation, and then you see that what kind of things it can do. So you can see here I like, if A is written, A I like A. So if both are there, it will give the answer as a 1. If ABC is like I like B, it means if it contains capital B, then it will like if it is similar to this or not. So ABC is not similar to B, so that's why it is giving 0. Similarly, now if you want to just search through B only, you don't know what is ahead of B, what is after B. So you can put this kind of underscore, that anything can come ahead of B, anything can come after B. Or this is just for case sensitiveness. If you just put this underscore and then this percentage sign is also there. So percentage sign is after B, any letter can come. And this I like tool is okay when you have any data, like it is case sensitive. If you have capital also, small also, it will work. So here you can see capital A and A is written, then is also giving answer 1, and capital A and small a is also written, then also is giving 1 answer. But if you write A and B, obviously both are not same, then it will give you 0 answer. Here we have just written ABC, I like B. Then what is there? It is not having just B, it is having ABC. It means only B is not there, along with B some other letters are there, that's why it is giving 0. So if you want to take into consideration other letters as well, then you can add this underscore. Underscore will take one letter ahead of B, one letter after B. And then if you want to take whatever kind of characters are there, let's say 5, 10, you don't want to restrict the limitation, then you can add this percentage sign. So percentage sign, it means it can consider any number of characters. Either after B, even 5 characters are there or 10 characters are there. In our case, after milk, let's say milk center is there, milk dairy is there, whatever is there, it will consider it. So what we have to do is, we are interested in word milk. Okay, so first of all, if I will write milk and the operation which I have selected is I like. So now it is case sensitive. So it is consider all the facilities which have either small m or capital M, or all the four letters are capitalized. So it will consider everything when I put this I like operation. But now ahead of milk, anything can come, and after milk, anything can come. Let's say milk dairy. So after milk, anything can come, or let's say XY, Amul milk dairy. Then ahead of milk, anything can come. So to accommodate that, I have added this percentage sign, which means it can accommodate any letter or character ahead of milk. So now I am not, I have removed this case sensitiveness thing, as well as the how many characters it can accommodate. So also you can see that now our expression is valid, and here you can see the feature and preview. So if you just go ahead, so it will give you for the given feature what will be the answer, either it will be 0 or 1. So here you can see wherever it's written milk, it is giving 1. So see here they are also used word doodh, which is also similar to milk only. So if you have your data very complex, and let's say if we are finding out schools, so for schools sometimes they used word school, as well as sometimes they use word as a vidyalaya also. Or similarly, if we have bank facilities, So in that case, what will happen? Sometimes it is just bank or SBI bank or a BOB bank or any bank, or sometimes they will just write SBI. That we know that it's a SBI bank, but they will not provide full name of bank, which is SBI. So on those cases, we have to add something additional expressions along with it. So that thing we can edit in the expression, and we can make the expression as long as whatever you want to do. So that is like how you can find out the different things. So right now we are interested in milk facility only. So we'll not consider any other words as well. So this is the final expression which we end up with, and I will click on OK. And then I will just click on run. So now I will just rename it. So that facilities, now you can see those like with a red color are all the agricultural facilities, and from that this like dots with the violet color are showing the properties which are related to the milk production. And you can see that here Anand and Nadiad, where the Amul dairy is there, you can find so many milk production related the facilities. So whatever the facilities are there overall, out of that most of the facilities are related to the agro field and related to the milk only. So these are the regions which are having milk facility. Yeah. Anything?
Yes, I was just wondering how doodh also got extracted when we have asked for milk.
So we ask the word milk only. Okay. They are synonym, but we are not adding that as a expression. It will not consider automatic like synonyms. So we have to add that thing. So how we can do that is, like if we are interested to add up all the facilities, we can just do something like this, that
No, no, no.
this,
It automatically came, right? Doodh got
no, it
selected.
it
Was
got
not
removed. It got,
accepted.
no, it is
Removed.
not.
Acha, acha.
Yeah,
Okay,
it
okay.
did not select it. But like I will just cover it. Like if you want to put it, so we can just write it down like this. I like percentage. So we have milk, and along with it, we also want to consider the milk, sorry, doodh also.
Then and or something like that,
We
right?
have to use or, because if we write and, then it will consider like both things cannot like consider it the same.
Yeah,
So
yeah.
either milk will be there, either doodh will be there.
Hmm.
So here we can search the word also. What is it exactly? So this is C TOOTH.
But here, features that we were browsing through after writing the expression,
Yes.
huh, the features that we were browsing through, there, without writing this or expression, we had only
No,
written the.
no, it
Uh,
was zero at that time.
oh, okay. I was doing simultaneously. I also got that dude. I was wondering, I have not written that expression. How did
We
the
can
dude?
check it. We can check it. Wait,
Yeah, yeah.
just take it. We'll just explore it. See, dairy, it is giving zero. Uh,
Oh, it is giving zero. Acha, acha, acha. That is how you browse through and your
yes.
preview. This thing is
Preview
the
is one. It means the our condition is right.
right, right. Got it. Understood.
Okay.
Yes, yes. Okay, okay.
So we can write this doodh also, and like similarly, we saw that something related to the dairy also is there. Why not we use that as well? So, so either any three thing can work out. Okay. So we can put combined conditions like this, and then we can run it. Now you can see, like if I just compare the uh, previous two facilities, I will just keep this layer. So you can see this green color facilities, which is before we excluded that, because in this particular region, whatever the data naming convention they did is they are using the word dairy only. So can anyone tell me like why this kind of thing is there? I mean, this is you see that data sets is like concentrated in one particular area or one particular region only. So can anyone tell me just why this happened? Like,
Because
see,
it
first
is
thing they use different
having the
words. Okay.
grass that the cows. Okay.
So what thing is there? It is you can identify human behavior from this that this data set is generated by some humans only. So while they do go for survey or while they're doing this digitization operations, so if some people which lives in this region, they are more acquainted with the word milk, but some which who are like living in this area, they are more acquainted with the word doodh. So you can see like how different words they are using in their retail like language. So it's like a kind of digitization is done by the two different people or two different organizations. So we can put that kind of conclusions and we can see the regions which are being highlighted there. So that is just a like good conclusion which we can end up with by analyzing this kind of data sets that how they pronounce the different things as differently. So that's a thing like extraction. Then we have one more tool which is extract by location. So here locations it means that let's say now I have this milk facilities, okay, and I want to see all the milk facilities which are there in this Anand district or Nadiad district. So for that, what I have to do is I have to add the shapefile of that particular district, and then after you can select like milk facilities which are situated within this Anand district, or milk facilities which are situated within the Gujarat, or milk facilities which are situated within the Ahmedabad. So you can give any shapefile layer and you can say all the facilities which are coming under that layer. So select those facilities. So here what we are doing is we are selecting based on the locations. So that thing, if you want to do that, first of all, we have to import the shapefile of districts. So for that, you can go ahead in the data source manager. And then after you can go to this common data folder, which we have given to you. In common data, we have a folder such as administrator boundary database. So from that, you can import the district boundary shapefile. And we'll just put it at the back. So now we have this milk facilities. So we want to see how many milk facilities which are coming in this particular district. So first of all, we will see the attributes of this district. So this district is Kheda district. So we'll see like how many facilities are coming within the Kheda districts. So first of all, we will extract the Kheda district from the entire Indian district file. So for that, we will use this extract by attribute thing or extract by expression. You can use anything. So we'll select our district boundary and we'll just create a field. Now district, uh, all unique. So it should be Kheda. So district equal to Kheda. Here just one word is there, so we do not use this I like or like operator because we just want to find out just one particular district only. So just we will run it and we got this Kheda district. Now I will just remove the entire file. So now I have just this particular layer which is Kheda. Just rename it. So I have this Kheda layer and the facilities of milk facilities which are there inside. And I want to now extract all the facilities which are coming inside this district. So for that, I will use this extract by location tool, milk facilities which are within this particular Kheda district, and then I will run it. So now you know that it has selected all the facilities which are within this district only. So this is using the location specific information and then they are finding out the facilities which are situated within that particular region. So these are the two different thing is there. So we have the tools like extract by attribute, extract by expression, and extract by location. So I think now all of you are aware about of it. Any confusion till now under how to use these three different tools of selecting or extracting the different data sets?
No, all clear.
Okay. So now we will see rest of the tools very quickly because those are similar only, but instead of the extraction, it will just select only. So basically, I have all these milk facilities data sets. Okay. And what I want to do, I will instead of extract, I will use select by location tool. So this tool is same only that like we have the milk data sets. So milk datasets which are within the Kheda district, and I will just run it. So what you will get is it will not create a new file. Instead of it, whatever the file you have, let's say I have selected the milk file. So if you go and check out the attribute table, it will select all the files which are, it will highlight in attribute table which are like within the Kheda district. So you can see highlighted files are with the blue color, and if you see in the given layer also, all the selected points looks like highlighted with the yellow color. So it will not extract the data and it will create a new file. Instead of it, it will keep it in same file, but it will highlight the data sets. Now, if you want to export this data sets, you can right click and you can export. And export here you have two things: save feature as, it means it will save entire feature, and save selected feature as, so it means it will save only the selected parameters only or selected features only, so which is highlighted with the yellow color. So like this, you can save data set. So here you have to go through two different operations, but whereas if you are using the tool extract, it both the things can be done in the one single go. Now you can ask if like we have to save this thing differently, then why should I use this particular tool which is select by location or anything, select by attribute, select by expression? Because if I want to save data, I have to save it after using another tool. So why to do both the things differently and not simultaneously at a single time using the tool extract? So here the good thing with the select tool is that we will start with the entire facility datasets. Let's say this is the entire facility datasets. Now we will use this tool select by expression. Now let's say what we will write in the condition is first of all, let's say we want to select all the facilities which are related to the medical facilities. Okay. Now it is select, so it will not save any file. That's why you cannot see any option related to the saving of file. And now we will run it. So now from the entire data, it has selected the medical facilities. Okay. Now we will use the select by expression tool one more time. And now in medical also, let's say if we are interested in some particular data sets, let's say we will use the facility description. And we are interested in, let's say, primary health center. So we are interested in what, like primary health center, or let's say we write the veterinary. So we are interested in all the hospitals related to the veterinary or animals. So we will write this word similarly what we have written earlier. I like uh, comma uh, percentage, and we will write the word VETERI. So we'll write the word veterinary, and then after we will click on OK. Now here you can see modify current selection by. So here it is giving you option that you want to create a new selection, or within the medical only you want to see the veterinary hospitals. So what you can do is you can just click on this adding to current selection. So now whatever the data is already selected, it will just search into that only. So adding to the current selection. So now from total medical data, it has selected all the veterinary hospital data only. You can go to attribute table and you can check that as well. That now, if you scroll it further, you can see that wherever it has got selected. So the thing is, you do not have, like, you can save the storage space in your system. That if you are not interested, just first select this, then select this, then select C. So you can do the operation continuously on the same data. But here the one drawback is, if you will select this as a new layer, then you will lost all the information which you had earlier. So that is one drawback with this. So that is just a differentiation between the extract and select tools. Otherwise, it is similar only, such as the select by attributes, select by expression, and select by location. All of these three will work same as extract. But the only thing is, it will not create a new file. Instead of it, it will select the parameter or the facilities within the given file only. Are you guys clear about the operations, select, extract, and select?
Yes, yes.
Yeah. And then this other four options are there, which is random extract and random select. So let's say you have some questions that some inspection is coming on, and then select 10% school for the inspection related to this Swachhta Abhiyan. So that is just, it will select the data randomly, like select the 10% random data or select the 100 random schools. So these tools are for that only if you select the random thing. But this kind of questions are very, like, use cases are very limited. But I will just show you quickly that random extract. So you have to give the facilities, and then here it will ask you whether you want to select the number of features or percentage of feature. So number of feature, it means select 100 schools from the facility layer, or 100 any 100 random facilities. And then if you write percentage, so select 10% random facilities, select 20% random facilities. So it is like that, and just if you click on run, it will give you the either 10% or 100 facilities, which whatever you have selected. So that is all about random tools. And this topic is all about vector selection. Any doubt till now?
No, no doubt. No doubt.
So what we discussed till now is, if you have large amount of vector data sets, how to narrow down your search, and how to select the particular data for any given applications. So here applications will be like, now we have selected the milk centers which are presented in the Kheda district. So now if we want to create a new milk mandli or milk center, then what will be the optimal location? So what kind of further questions we'll be having is like, now the new milk center should not in the range of 1 kilometer from the existing milk station or milk centers. Okay, so it should away from, like, it should be near to the highway, or it should be near to the villages. So if you want to construct something now onwards, you have multiple criteria which is related to the range, and we also known as a proximity in case of GIS terminologies. So the next topic will be like how to perform this proximity analysis. So
Site
what?
suitability.
Yeah, site suitability basically. But right now we will not entirely go on to site suitability. We will just restrict ourselves to the location, like range specific only, like how
Okay.
far it is. In site suitability, along with it, we have some other parameter as well that we will discuss after this topic. So right now, what we did is, we have this Kheda district, and we extracted all the locations within the Kheda. So we have this two things. Okay. So all the milk centers which are within the Kheda. So we have shown that thing. So we are going to work with that. So now that is known as a buffer. So buffer, it means what? First of all, we have one question that let's say it should have connected well with the bus stands. Like all the milk centers should be connected very well with the bus stands. So our first question is that how many bus stands are there within the 1 kilometer range of the milk centers? How many bus stands are there within the range of milk centers. That is our question that we want to solve. So for that, we have to create a buffer of 1 kilometer around all the milk centers. And in that buffer, we will select all the files which is representing bus stand. So first of all, we will create a buffer of 1 kilometer around all the milk centers. So we will select this tool buffer, and then you will select the files related to the milk. But now then it will ask you to provide the distance, that how long buffer you want to create. So here it is given the degree because our units of our data is in degree. So it is giving us a warning that distance is in geographic degree. Consider reprojecting to projected local coordinate system for accurate results. So this data set is in degree, and we have to convert the data from degree to meter, because whenever we are interested in buffer or any other applications, our unit should be in meter. So first of all, we will transform our data from degree to meter. So now onwards, if you have doing any analysis, the first step is to convert your data from degree to meter. So for that, we have tool reproject. So we have this reproject layer tool. Here you have to select the milk file, and then after you have to target CRS. So we are interested in coordinate system which is in meter. So you can select something like 43 north, which is in meter. So now I will not go into detail about this coordinate system because it needs a separate one lecture for that. But you can just explore this coordinate system, and you can see the units is in meter. You can just see the informations over here. It will be written that the unit of this coordinate system is in meter. So that's why, like, you can see length unit is in meter. So we'll go with it, and our region is in this Gujarat only. So it is covered by this 43 north. That's why I'm selecting 43 north, and I will select that, and I will reproject my layer. So I think I have reprojected the entire layer. So I have to reproject just this milk layer. So I have reprojected my milk layer. So milk layer, it means it is considering all the milk facilities, but we are we are just want everything which is in Kheda only. So I think we have selected wrong layers. We have to select this particular layer, which is extracted location. We'll rename it. So we'll get to know Kheda milk. Now we will reproject our layers, Kheda milk, and then 43 north, and run it. So I will rename this name also as a Kheda milk centers, and unit is in meters. So I will write underscore meters. So it will be like useful for me. So now if you just right click, go to property and check the coordinate system, it is in a meter now. So now we are good to go with the buffer tool. So I will select this buffer. I will select the Kheda milk meter. Then I will I want to create a buffer of 1 kilometer, which is around 1000 meter. So I will write that, and then you just run it. Now you can see it has created around all the points where this milk center was there, or milk related facilities at. But you can see now here there are different facilities were there, and so while creating a buffer around it, it has created the three different buffers of 1 kilometer. So what is happening here is what is more preferable is we can merge all the buffers which are here into one buffer, because it is like one common area. We don't want to analyze them separately. Here similarly over here. So for that, while doing the buffer analysis, when you select the tools, you have to click on this dissolve result. Dissolve result, it means whatever the different files are creating, it will dissolve into one single buffer. So you have to click on this particular option, and apart from that, other options such as segment, round, join style. So if two like line features are there, so how to connect two different lines, what kind of end tool round should you use, or some kind of sharp edges you want to use, millets you use, flat you want to use. So it is for that particular purposes. Uh, and then we'll just run it. So now the final buffer which we got, in that you can see now it has merged all the files. Earlier it was like this, but now it has merged all the data sets. So now see, whatever the buffers are coming in near to each other, it has like merged along with each. So now we got a buffer related to the milk facility on 1 kilometer. And our next question is that we want to find how many bus stands are there in this given buffer area. So for that, now we will click on this layer. And then after, what we will do is we will open up our facility layer one more time, and we will select the facilities which is related to the bus stand. So we will go and do the vector analysis or vector selection one more time. We will see extract by expression. We'll put the facilities, entire facilities, put the expression, field, field description. Here I will write buzzword. So everything related to the bus stand, it will come. So I'm just interested in word bus. So either we'll just check any, is there any word related to stand as well. So here see the just mostly it is a bus stand, but here somewhere it's a pickup stand is also written. So what we will do is we will also try to add those as well. So for that we can have this word stand as well. So either, and then we will just run it. So now it has given me all the things in entire Gujarat, not in the just Kheda. So we'll close the entire facility layer. So all those facilities which you are seeing now is related to the bus stand or just bus word, or either just stand word. So we can just click on any one quickly, and just we can find out it is bus station, and then this data is bus stand, and this data is bus stand, and we can just check the inside the buffer zones also. So you can see we are interested in this kind of facilities, which is their pickup stand is there. So here its name is pickup stand is there. So we are interested in identifying how many such facilities are there within the 1 kilometer. Okay, so now what we will do, so this buffer is there, so that shape file is there, and we want to see how many facilities which are there within that shape file. So here something we have to do related to the locations. So we will select the tool select by location, or sorry, extract by location, because we are interested in finding out. So all the matching features which are within this buffer. So we have two buffered files. So we will remove the one which we don't want. And here also we will change the name. So here, I mean, I'm not saving my files to reduce the storage or do not save it in my drive. That's why I'm saving all the layers as a temporary layer. But when you do your actual project, save the layers, do not save it as a temporary layer. So bus stands which are within this buffered region, and then just run it. So now the final answer. So you can see all the bus stands which are there in this buffer region. So you can see this is the bus stand which got selected, which are within this buffered area. And if I right click and open the attribute table, I can count the number also. So there are 39 bus stands are there in Kheda districts, which are in the range of 1 kilometer from the milk related stuff or milk related organization or shop. Is it clear?
Yes, I could not keep up with your speed, so I've been looking and I've understood.
Okay, so I give you a time of 2-3 minutes. You just do quickly recap. So what we did is our question was how many bus stands are there within 1 kilometer range of the milk centers or anything related to the milk facilities. So for that, first of all, we find the buffer of milk facilities. But when we started it, it showed us one warning that your data should be in meter. So first of all, we converted our data from degree to meter using the tool reproject. So we converted our data sets into meter using the coordinate system WGS UTM 84, UTM 43 north. Then we got the data into meters. Now next step is to create a buffer. So we created a buffer of 1 kilometer around this milk points, which is this one. So red points which you can see here. So we have created a buffer, and here we have clicked on the dissolve option to automatically dissolve the whatever the buffers which are combining with each other. So we have clicked on the dissolve option there. Once we did that, we want to identify the bus stands which are there within this buffered region. So we can do that using the tool extract by location. But the thing is, we need a data layer which should represent the bus stand data. So for that, first of all the from all the facilities layer data sets, we will select the data related to the bus stands, or the name is just stand, or the name which includes the word bus. So we have extracted the data using the extract by expression. Once we extracted all the data in Gujarat, which is representing word bus or word stand, then after we use the word tool extract by location. Using that, we found out that all the bus stands which are within this buffered region. So which gave us the all the 39 facilities, milk facility, bus stands, which are in the 1 kilometer range of this milk facilities. So everyone is clear with what we did?
Yes.
Okay. So now similar to this, you have multiple questions that select a bus stands which are within the 1 kilometer range of the national highway, or select the properties which are within the 1 kilometer range of the national highway or the state highway. So here what will change is just file which you are using as a buffer. Here we have used point data. If you have the question related to the road buffer, you can select the file related to the road data sets. So how it will be useful to us is, let's say if like NHAI wants to widen one particular state highway, the original width might be something and they 12 meter and they want to extend it from 12 meter to something else, let's say 15 meter. This is just rough numbers. So first what will we do, we will create a digitize the shape file of that particular road. Then after we want to make an extra buffer of 300 meter. Let's say we want to go from 800 or sorry 900 meter to 1200 meter. So around 300 meter buffer we will create around the highway, and then after we will see, like we will import the data related to the facilities or related to the polygons which represents the buildings. And then after, what we will do, select the polygons which are within the extended buffer, which will give us the idea of how many properties can be demolished under this widening of this project. Similarly, if we have the data related to the tree cover or the data related to the tree, we can find out that how many trees are going to be cut down because of the expansion of highway, or how if we have jungle passing through the area, so how many part of jungle or how many trees inside the jungle are going to be cut because of the expansion or the widening of the given highway. So these are the just simple applications of this buffer analysis. You can think about multiple applications and multiple case studies or multiple questions which we can solve using this buffer data. Now, in this buffer, there are different kinds of buffers are there. So this is just simple buffer, but along with that, if you just write the word buffer over here, you have multi-ring buffer also. So multi-ring buffer is it will create a, let's say, buffer at 10 meter, 20 meter, 30 meter, 40 meter, 50 meter. So whatever the rings you will tell at given the interval, it will create the 5 different buffers. So here we have buffer at 1 kilometer, but if you want to create a buffer at 1 kilometer, 2 kilometer, and 3 kilometer, so what we can do is we can select the this milk Keda milk points, and then we want 3 different rings at like buffer of 1000. Well, we'll do it for at 500 meter, and then just click on run. So you can see now it has. So this is our original buffer, which is at 1000, and you can see it has created a buffer at 500, 1000, and 1500. So you can create this kind of multiple buffers also. This will be useful when you are making something related to the nuclear power plant, or if you are putting any kind of mobile tower or electric tower, and you want,
Earthquakes also.
yeah, earthquake also. So there will be different zones. So wherever the earthquake or any kind of this kind of phenomena are happening, what is the critical zone? Let's say the nearest 1 kilometer zone is the critical zone. Then the further 1 kilometer zone we have to pay moderate attention, and then the next 1 kilometer zone is not in that risk. So we can plan our operations accordingly. So this kind of applications are also there. And then we have other buffer also, that's a rectangle buffer, single sided buffer. Instead of two side, if we just want one side, we can also do that. Then we have this variable buffer. So variable buffer is like if you are having national highway, state highway, and then major roads in the town. So what is the thing is you want to create a buffer of 1 kilometer around the national highway. Then you want to create a buffer of 500 meter around the state highway, and then you want to create a 300 meter buffer of district highway. So district roads basically, or primary, secondary, or tertiary roads which are there in the district. So you can generate the variable buffers, or like sorry, buffers according to the variable dimensions also. So if you want to do that, what you can do is like you can select the layer. It should be there in the attribute table. So in attribute table, you have to create an attribute which will define the value of buffer. Either you want to 1000 meter, 500 meter, or 300 meter. So that kind of file you have to create in your attribute table. Let's say if we have this particular Kheda milk of file, which is this one, let's say. So what I can do is in attribute table, I can add one more column over here, which will specify the amount of buffer which is required. So wherever milk dairy is there, let's say I want a buffer of 500 meter. So I'll write 500, 500, 500 everywhere, wherever the milk dairy is there. Then if we have something else, let's say we have the bus stand, and I want to their buffer of 1 kilometer, I will write 1000 there. So it will generate the buffer according to the attributes which is given into the attribute table. So these are the different types of buffer, and then it will be useful for the applications such as proximity. And these things you will learn more in the upcoming, I think in the last week of this course, where you will be learning more about GIS. I think in the next week also it will start. So there you will like learn more about the theoretical concept, how to create this buffer, what are mathematical expressions behind it. So those things you will learn there, but this is just hands-on on that. Any doubt in this?
No, no doubt.
Okay, so this is quite simple applications of buffers. Now we will see the overlay analysis. So overlay analysis is like, let's say you have this kind of buffers. So further, like you generate the buffer around the milk center, buffer around the schools, buffer around the bus stands, and then you want to see, I want to find a property which is 1 kilometer from this milk centers, 1 kilometer from the bus stand, and 1 kilometer from the school. So I have three different criteria. So I will generate the three different buffers, and ultimately what I have to do is I have to combine these three layers in such a way that it should follow all the three criteria. Okay, so that operation combining the different layers of GIS within each other, that is known as a overlay analysis. So now we will go into doing that analysis. And to do that, what we will do is we will solve one questions, real life case study. So which will like give you more idea about what we are doing. So for that, first of all, just create a new project. So whatever we did till now, if you want to save it, then just save it. Otherwise, just create a new project. Now you can go to this data source manager. And now we will go to this day 6 folder where it is given this tutorial data, and then four kind of data is given: building, restaurant, roads, and school. So open all the data sets: building, restaurant, roads, and schools. Building, restaurants, roads, and schools. Everyone open the
Can
data
you
sets?
just hold on for 1 minute? Huh?
Yeah, sure.
Could you please redirect me to the files that you're
Yeah,
expecting me to
so
open?
it is under the day 6 overlay analysis. Inside that, tutorial data,
Mm,
and inside that,
mm.
four files are there: building, restaurant, roads, and schools. So open
Yeah,
all the
okay,
four
okay, got
files.
it. Yes, got it, got it.
Okay. So
Mm.
now what we want to do is we have one question which we are going to solve right now. Let me open it. You will find these things in the manual which I have shared earlier in detailed description. So yeah, so the question is like this, that you have to find the suitable real estate properties which we have given you the data such as building. So if we in buildings, if you see the attribute table, there you will find that ID is there, OSM type is there, building, whether it's building, rental, retail, or what is there, it's given health, whether it's a commercial building or not, it is also given. Who is operator, height data set is given for two building, it's given, otherwise it's not. And different layers, it's man-made or the commercial security. So this kind of informations are given. Some of it is not there, but these are the attribute. If you have data, you can add those things and in the entire database like this. So we are going to use this data sets where we are interested in just area of the building as of now, because we do not have entire data set with us. Like what is the price of that building, or how many rooms are there, what is the height of the building. So if you have that access also, or if you have collected by yourself, you can use that criteria as well. So the first criteria is that given building should be in the Swellendam. So it should be in the Swellendam area. So we have to check that first of all. So for that, what we will do is we will add the base map. So I will just add my Google Maps. And you can see here that it is all the files which is given to us are in the Swellendam only. I mean, if you see this Swellendam town and whatever the data which is given to us, it is inside the Swellendam only. It's not outside it. So the first area criteria, which is that it should be in Swellendam, it is automatically fulfilled. So we do not have to do anything there. Now the next criteria is that it must be within the reasonable driving distance of a school. So it should be 1 kilometer from the school. So now we have to create a buffer of 1 kilometer for school.
Yeah, first we have to search for schools, then create a 1 kilometer
Here
buffer.
we have already given the data of schools. So see what we already have
Yeah,
is
yeah.
school, road, restaurant, and building data set. So we do not have to search. If it is not there, we have to search. Okay, so the data related to the school is already given to us. But the thing is, we have to verify that whether it's in meter or not. Because if it is in degree, then we have to convert into meters because we are interested in buffer. So right now, if you see, right click and check the units, it is in degree. So first of all, we have to convert all the 4 layers from degree to meter. Is that clear?
Yeah, yeah, yeah.
Okay. So we will use the tool reproject. Now we will click the button school like school layer, and this coordinate system is in 34S. So I have already worked with this data set, so I know. But this data is in Africa, South Africa basically, and this coordinate system which is useful for this area is 34S. Um, so that's why I have selected that one. And then you have to give the name of the reprojected layer. So I have done for one. I will just
Hold
rename
on,
it.
I'm getting different versions of 34S.
Okay.
Um,
So in that, what you have to do is you have to use uh, 34. So you have to use this one WGS 84 underscore UTA sorry slash UTM zone 34S.
okay, okay, got it.
WGS 84 UTM zone 34S.
Yeah, got it. Okay.
So everyone just reproject your all the 4 layers into meter.
Or full years. Okay.
Yes. So please do this step whenever you start any analysis. Convert your data into meter because if you will not do this step, you will end up with doing so many errors. Once you are done, let me know.
Yeah, hold on. So it's roads, schools, buildings, and restaurants. Yeah, yeah,
Done.
done.
Now what you can do is you can remove the layers which are in degree, so it will not make confusion for you.
Hmm.
Okay, so I have 4 layers of all the data. Okay, I have not done this.
Why is your
Actually, I have
um,
used it. Not, I have not done building layer properly. That's why.
now my problem is what I can't see your bottom information bar of QGIS because your Windows bar comes in between, so I cannot see if my information is matching your information. That.
Is it fine
Huh.
now?
Yeah. I was just checking the coordinates.
So do you have like this all the 4 layers in meter?
Yeah.
Okay, so now we will start with the first, second thing, which is reasonable driving distance from the school. So we have to create a buffer of 1 kilometer around the school. So first of all, we will do the buffer,
Mm,
and in buffer we will select school, and for school we will select 1 kilometer, means 1000 meter, and we will click on dissolve also, so that it will
mm,
like overlap all the features if it is coming like nearby, and then we will
mm.
run it. So we will end up with like this.
Yeah.
Okay. So now
Mm,
the next one is it should be have related to the area basically,
mm,
that it should have area of more than 1000 meter square.
mm,
So I think we will keep it hold because
mm.
first of all, let's say we will see the other thing, and then we will
And
come to the
expression
data.
will come, no? I think in attribute table.
Yeah, so we know that we have to go to attribute table and we
Mm,
can find out the area, and then we can just give the like vector selection
mm,
that it should be greater than 100. But let's see
mm,
what else is there.
mm,
So closure then 50 meter to main road,
mm,
and closure then 500 meter to restaurant. So we have
mm,
buffer of main road and restaurants. So first of all, I think we will finish that, and then after whatever will we end up with, then after we will
mm.
find the area.
Area, okay. Mm,
Oh, so the next one is main road 50 meter buffer. Okay. So
mm.
first of all, we have to see the roads,
Roads. Mm,
and from roads we have to extract the main roads, because
mm,
here we will see in attribute table what kind of roads are given to us. So here, let's say in highway, some residential roads are also given, tertiary roads are also given, service roads are also given. So we don't want that, because if we want to drive, then roads which is like residential roads or pathways will not be useful to us. So specifically those informations we do not consider.
mm,
So first of all, we will use this select extract by expression, and we will select the main roads only. So we'll go with extract by expression, roads, and then fields and values, highway, and we'll just check all the units. So highway, and then we can write in. So this is one more operator in. So what does do is that it will just check that whether whatever we have selected, which is inside that or. So A in A and B. So if A is there inside this list, it will give 1. Okay. So
Okay.
we want that kind of thing. So what we want inside the highway is, so now we will select the highway parameter one more time. We'll go to field and value, highway, and we'll click on all the units. So what we want is, or either what we can do is, we can, okay, we will do this only. So highway in, we don't want footway, so we'll not select that. We don't want path. We are interested in primary highway, so we will select primary, comma, secondary, or just roads. Residential we will not consider. Secondary we will consider. Service road also let's consider because it's like fine. We can walk through it. Tertiary road also we will consider. Trek, we cannot consider it. It's just normal trek. Trunk we can consider. Then trunk link, I think we'll take it. And then unclassified, so it is unclassified, so we don't know what is going to be there, so we will not go with it. So we will just right now select this route much, click on OK, and just run our algorithm. So now you can see it has given us all the roads which are like this. So earlier it has all the roads, but now it has given us specific roads only. Okay.
Correct. Yeah.
So I mean, we can put this kind of criteria according to us, like what kind of property we need. So that's thing. Now we will see for road we need a buffer of 50 meters. So now we are going to go with the buffer. So I will just click on buffer, select my layer. I will write 50 meter, click on dissolve and run it. So I got the buffer of roads. So name it as a road buffer.
Got it.
Are you getting similar to me?
Yes.
Okay. Now the next criteria is related to the restaurant. So it should be closer than 500 meter to restaurant. So it is just straightforward. We'll take a restaurant layer and we will make a buffer of 500 meter. Okay.
Okay.
So buffer. I will select the restaurant layer and a buffer of 500 meter. Dissolve and run. So we got this. So now it should follow all the 3 criteria. So what we can do is we can take a intersection. Okay. So this intersection, either you can write in this processing toolbox intersection. So there will be like tool name as a intersection, which is under vector overlay. And if you just see like processing box also, that vector overlay is there. So if you go there, there are different tools such as clip. Clip, it means if you want to clip something like as a cookie cutter. Then difference, extract, intersection, line intersection. So there are different tools are there. And right now we are interested in intersection. Now in intersection, you can see at a time we can give just 2 layers only, input layer and overlay. So first what we will do, we will take any 2 layer. Let's say we will take a restaurant and school. And then whatever the answer we will get, that we will do the intersection with roads.
Wait a minute, I think I should rename my buffer, the latest one that I've got from restaurants. Yes. No, I'll just rename that because otherwise I'll get confused. buffered restaurants. Okay, now we are going to intersection.
So intersection, first we will do with restaurant and school. You can go with any two, like first restaurant and roads, or schools and roads, any two you can take. So we'll go with the restaurant and schools, and I will run it. So now,
Was it matching features? I don't.
you should name your layer properly.
Yeah. No, matching features was roads.
You just see your layer and rename it, and then take your time.
Disable everything. So right now the ones that we want to intersect are the buffered restaurant, right? And then
Buffer school.
the buffered school. So I'll rename this to buffered school. Wait. Okay. Then
you go something like this, which is
yes.
So
But I've not
now,
intersected yet. But yeah, I'm getting these two. So right now a buffered restaurant, buffered school, and what else?
first do the intersection of this
Buffered school.
buffered road you need.
Yeah. So I'm just renaming everything first. And what else?
Road buffered.
Yeah. So buffered restaurant, buffered road, buffered school.
Oh, yes, that's three only.
Three only. Acha, okay.
Yes.
I got them. Okay.
So first
now
of all, we will take restaurant and school.
Okay. Yeah. Now I will call this intersection restaurant and school. Huh?
Yeah.
I'll have to name this.
So it's very important to give proper name.
Okay.
You got something like this?
Yes, I did. Yeah.
Okay. Now we will proceed further.
Are you there?
Yeah.
Okay. Huh.
So now we will proceed further.
Correct.
So we will use this intersection one more time. Then we will select restaurant school intersection, which we just got, and with roads we will do. So you will end up with something which is like this yellow color.
Yeah. So this is the final answer, right? But area is not yet done.
Yeah, area is not included yet. So school, restaurant, and roads. Now,
so I'll just disable everything else.
Yeah, you can delete or you can just uncheck everything.
Yeah.
So you can see now how many buildings are coming within that yellow color portion. But now what we are interested in, we want buildings which are greater than 100 square meter. So first of all, we have to extract the buildings which are coming within this yellow region. Okay. So how will we do that?
By location?
Exactly. Extract by location. Extract by location. The final, our buildings which are within this final intersection layer, which is your restaurant, school, and roads.
Are within.
Which are within or which are intersected, or you can just write which are within.
Final before area.
Okay, and then just run it, and you will get, see here, which are within means whatever exactly inside. If it is in between also, it will not select. Okay, so you got all the properties which are inside those things.
Just disable the others, no? I mean, remove the visibility of the other layers so that I can make out whether my answers are correct.
Yeah, like this. Okay.
Yeah, correct. I've got that. Yeah.
Now we are interested in the final area. So I will right click to the layer which I extracted just now. I will go to the attribute table, and I will add one column of area at the end. Okay, so for adding area, can you recall what we did uh,
Yeah,
last time?
it was field calculator.
Yes, exactly. So we
Open
have to
field
click on open
calculator.
field calculator.
Mm.
There we can write area. Instead of whole number, we can select decimal real number. And
Mm.
here we can write the expression for area, which is dollar area.
Okay.
So our units are in meter, so it will give answer in meter square.
Mm.
So we will just click on OK.
Mm.
So it has added the column of area
Where last? Okay,
at
okay.
the
Mm.
end.
Mm.
So our area is ranging from 9 square meter to 1150 square meter.
How did you see that?
So you can just click on this area column. So it will
Yeah.
arrange
Ah,
ascending.
sorted. Okay, okay. Sorted it. Fine, fine. Yeah. Mm.
So now we will just close this attribute table. We will use
Mm.
extract by attribute.
Mm.
We will select the final locations which we extracted. And then we have to select the last column, which is area. So you can see
Mm.
now here so many attributes are there. An area which is greater
Mm-hmm.
than 100.
Greater than. I mean, the sign has to be greater than. Okay.
Yes.
Mm. Value. Mm.
And then just click on run. So now we've got our final answer that all the areas. So now you can see it has excluded all the areas which are small. So this green ones are like less than 100 square meter. This pink one are the final answer, which are like greater than 100 square meter.
I'll have to rename that.
Yeah. So finally you will get something like this. And now these are the options available to you. Now further, if you are interested in the properties that it should be near to, like I want to set my children into this particular three schools only. So how many
Mm.
school like buildings are near to that particular school? Or I want to
Mm.
live near the metro station. So you can add n number of expressions along with it, and you can do the intersection.
Mm.
And finally, we will get answers.
Yeah.
Okay, so this
Okay.
is kind of overlay analysis in general. Like you will be having different layers, and then you will match up everything and you will get some answers. Similarly, some questions are there also there in the exercise, which in the manual which I have shared, which are related to the finding out the suitable cover habitats. So there the question is like that the site should have exhibit the steeper slopes, then it should have a forest vegetation code which is related to the 34 and 49, which indicates the land suitability. Then region should be located within 2500 feet from the stream, so it should be near to the river because animals needs water for drinking purpose, so it should be near the river. And then it should be away from highway, so it should be away from 500 feet from the highway. So this kind of things you will be having. Then one case study is there related to the too many liquor stores. So let's say if we take example of Delhi or some states where liquor stores are so many liquor stores are there, and we want to see the regulations that the liquor stores should not be located in the 1 kilometer from school, 1 kilometer from library, and 1 kilometer from parks. So first of all, we will generate a buffer of school, library, and park, and then after it should not like within the school as well, library as well, and park as well. So here what we will do, we will take a union of this three buffer instead of taking intersection, because it should not be from school also, or library also, or park also. So we can take a operation such as union over here, and then after we can find out how many liquor stores are there which in the union area. Then we can see that how many area in the city is under the restriction zone, and how many area under the city is in non-restricted area. So if we have a map of Delhi, and map of this buffered layer which we got. So from Delhi, we can cut down this buffered map, which is the restricted area. So if now any proposal will come related to the liquor store in that particular area, we will directly say no to that particular proposal. So this kind of analysis also you can do, and there are multiple analysis you can design by yourself using the data sets which I have shown you before. So like this, we can explore the different applications of it. Any doubt till now?
No, today whatever we did is clear.
So that's what we covered is everything about the vector data sets, starting from we have a large amount of vector data sets, how to extract a specific data set related to these specific conditions, then how to create a buffers according to the proximity which is given to us. And then once we have all the buffer layers, how to combine all the buffer layers and do the overlay operation. So whatever the applications which we discussed today is in that major applications is from intersection. But as you see here, this liquor store application, it has having the like we have to do buffer and yeah, we have to do union and then clip also. So you have to identify which kind of operations will be useful in your applications, and according to that, these tools are easy to use. Just select one layer, two layer, and then just do the union on this intersection or clip. So this tool is not like how to use it is not difficult, but what tool you should use at which time, that is more important over here. So you can do that thing. You can just plan out your study and just a few now. I think in the next class we will discuss on digital image processing, histogram stretching, histogram equalization, and some numericals related to it. So next lecture will not be hands-on. It will be like more on like some hands-on sessions will be there, which is showing the histogram in QGIS or changing the histogram in QGIS. So something will be there, but apart from that, next lecture will be like mostly on numerical questions we are going to solve it. So that we are going to do next lecture. Any suggestions for? And then next lecture we will solve some other thing related to the raster or combined analysis. We'll see.
I only wanted to know which are your resources for GPS and GNSS study.
My resource actually I have done that particular work during my bachelor's. So I have used multiple books. Particularly I followed the book named as Hoffman for GPS. It's kind of traditional book, but I mean, if you are interested, I will suggest you a one course which is there on NPTEL by JNK Ghosh sir. That
No,
course
I
covers.
went through that, but that is also not as clear as I would like it to be, because in order for me to understand what
Okay.
you taught that day for one of the sessions in GPS went too fast, and I am not clear as yet related to the signals that are involved in GPS.
Yes.
It's very, it's like memorizing. I don't want to memorize. I want to learn and understand. So, if any
So
resource.
I worked on real data sets, so I learned from their manuals. Like basically whatever the codes which is going there and coming back, so there will be manual that you are getting one file in that this lines should be specific to, it will give this parameter, this will give this parameter. So I mean I have learned through that rather than going through books.
Okay,
But
so learning by doing is helping
Yes,
more
yeah,
than
learning by
studying.
doing is the
Okay.
key. But I will share, try to share some of the YouTube courses are there. But I mean, unless you will do that thing, for you it's like just a memorization thing only. Unless you do, because those thing is like kind more of memorization. Unless you do it.
Okay, got it. Okay.
So for that, I mean, you can refer my PPT because in that I have attached some of the data sets, like how this code will look like in real life. So, I mean, I'm not sure that it will give 100%, but it will give you some idea that navigation data will look like this, or the signals which they are sending, it contains such kind of data sets. There is also one course or like on website only. It has every topic contained in it. That I will share the link. I will if I will find. So and one more YouTube channel is there on GPS by some US professor. So I also followed that one as well. So for basic concepts like what is ranging, what is different kinds of error, how they can propagate, and differencing and all. So I mean I will share some of the references. You can go through it. But apart from it, like major thing is you must doing it, or more thing is like memorization part.
Okay, okay, okay.
So we will wait next lecture with the digital image processing in detail and all the parts related to that. And yeah,
To what extent are we going to be learning DIP?
so in that whatever cover discussed in this NPTEL class, so we are going to do that only. But what I am trying is like we will solve entire part of second part of GATE question paper for 2020, 2023 and 2024.
Okay,
So
great,
we
great.
will try
Okay,
to
okay.
cover all the questions, but for some questions you might not know the prerequisite topics are not discussed in the NPTEL course. So there you just have to assume something what I will tell, and you just have to go with that. But I think I just gone through it just for like 5 to 10 MCQs are that which are having like some different concept which is not there in this NPTEL course, or which is like extensive of this course, which is this like some questions related to the filter on this high frequency low frequency filter and this convolution related questions. So those questions are there, but it's like those are very simple in nature. So I will try to cover that, but we will solve entire paper of part 2, so don't worry about it. So that's why
Okay,
like
okay.
we are going to spend like entire lecture on just question answer only in the next lecture.
Okay, fine. All right. But don't mark the answers already, just like how you did
Okay,
today.
okay. I forgot to put animations today.
Okay, okay, okay. Hmm.
Okay, so we'll keep that thing in mind. Yeah.
Yeah, all right. Okay. Thank
Okay.
you. Thank you so
Chalo.
much.
See ya.
Thank you. See you. Bye. Good night.
Good night.